Yeah, this is Dr. P.S. Ramaprabha, Professor, Department of EEE, Panimalar Engineering College. Today I'm going to take about Internet of Things and that IoT protocols. The content what we are going to see is IoT access technologies in that physical and MAC layers, topologies and security of IEEE 802.15.4, 4G, 802.15.4E, 1901.2A, 802.11AH and LoRaWAN. When we are coming to the IoT access technologies, which is actually address a physical layer, MAC layer, topology and security. Physical layer consists of the wire and wireless method and relevant frequencies. And also in the MAC layer, consideration at media access control layer, which bridges the physical layer with data link control. Topologies, the topology supported by the technology. And finally, security, the security aspect of the technology of all the IoT access technology. Yeah, when you are going for the access technologies in IEEE, we have five technologies. One is 802.15.4, 802.15.4G, 802.15.4E, 1901.2A, 892.11AH and LoRaWAN. IEEE 802.15.4, and this is actually wireless access technologies. In this, it is actually a low cost and low data rate device that is powered or on a run batteries. Low cost and reasonable batteries life enables easily installation using a compact protocol stack while remaining both simple and flexible. Next, when you are coming for the application of the IEEE 802.15.4, commonly founded applications are home and building automation, automotive networks, industrial wireless sensor network, interactive toys and remote controls. And the standard is well known as for the low complex wire devices with a low data rate that need many months or even years in a life. The protocols of the 802.15.4 are a ZigBee, LoRaWAN, a ZigBee IP, ISA 100.11a, wireless ART and threads. When you are coming for this IEEE 802.15.4 physical and MAC layers are the foundation of several networking protocol stack. These protocol stacks makes 802.15.4 at the physical layer and the MAC layer, but upper layers are different. When coming for the physical layer, in a physical layer of 802.1.15.4, it's actually 2003 standard specification. There are three physical options are, which is depending upon the direct sequence spread spectrum DSS modulation, and which is consist of the following frequencies: 2.4 GHz 16 channel with a data rate of 250 kbps, 915 MHz 10 channels with a data rate of 40 kbps, and 868 MHz 1 channel with a data rate of 20 kbps. And these are all the layers of the physical transmission. Only 2.4 gigahertz band is operated worldwide, and with this we can use 2.5 gigahertz for the physical layer, and 915 megahertz is used for other works. IEEE 802.15.4, which is in a 2006, 2011 and in 2015 also we have introduced the physical communication options, and we can also use and OQPSK, that is quadrature offset quadrature phase shift keying modulation, and OQPSK is a modulation technique that uses the 4 unique bit values that are signaled by phase changes. An offset function that is presented during the phase shift allows data to transmitted more reliably. And PBSK also used for the physical layer. This DSS is physicals employing binary phase shift keying, modulation. PBSK is specified two unique phases as its data encoding scheme. ASK, a physical layer. This is a parallel sequence spectrum, and physical employs amplitude shift keying ASK and a binary phase shifting key modulation. PSS is an advanced encoding scheme that offers increasing range, throughput, data rates, and signal integrated compressed to DSS ASK uses the amplitude shifts instead of the phase shift keying signal. IEEE 802.15.4 physical frame format, and this is a format for the 802.15.4 physical format. We can see, and this the first one is the preamble, and the second one is the start of the frame delimiter. So these two as a synchronization header, this carries out the 5 bytes. And when you are coming for the frame length, it's actually physical header, and physical header we need have the 1 byte, and remaining 0 to 127 bytes are used for the services and data unit PSDU. And physical header portions of the PHY frame shown in the figure. This is what it leads to receive the how much total data expects in a physical service data. And PSD is a data field which is used for the payload. And next, MAC layer. The MAC layer consists of networking becoming for device acting coordinator and new device use beacon to join 802.15.4, and this layer as the data from are also coordinated, and the MAC layer achieves these tasks by using the various predefined frame format. We can say this is a frame format for the MAC frame. First 2 bytes are used for the frame control and sequence number 1 byte, destination PAN identifier, and these are all the address fields. 4 to 20 bytes are used for the address fields and destination address, source PAN addresses, source addresses. And variables will be used, and MAC payload. This is a frame payload will be the MAC payload. Frame check sequences MAC footer, and this is a physical frame. This MAC frame will be in a PSDU will be consist of the MAC frames also. The MAC header field consists of the frame control, sequence number, and addressing fields. And frame control field consists of the frame type, addressing mode, and other control flags. And sequence number fields indicates the sequence identifier for the frame. The addressing field specify the sources and the frame. The addressing field specify the sources, and the destination PAN identifier field as shown in the source and the destination address field. MAC payload field varies by individual frame type. For example, beacon frames have specific field and payloads related to beacon, while MAC command frame have different fields present in the MAC. Footer field is it's nothing but a frame check sequences FCS is a calculation based data in the frame headers, and receiving side confirm the integrity of the data. And topology. IEEE 802.1.54 based upon the star, peer-to-peer or mesh topologies, and 802.154 network should be the same as the PAN ID, and this is a topology network. Security, the IEEE 802.5 specification uses the advanced encryption standards with the 128-bit key length and based upon an encryption algorithm for security and its data. The uses of AES like advanced encryption standard by the US government and its widespread adoptions in the private sector has helped it become one of the most popular algorithm used in a Symmetric. And this is a frame format for security. We can see here frame control, sequence number, destination PAN and destination address, source PAN, source address, auxiliary security, frame payload, and frame check sequences. We can see this is a frame control is taking as a 2 byte and sequence number is 1 byte, and totally addressing fields will be in terms of the destination PAN, destination address, source PAN. This is going to check the address and destination addresses, and this is the auxiliary security header, and this is comes under the MAC payload and is the MAC footer.